In 1966, British aviation legend Sir Frank Whittle was honoured for his services to the aviation industry. 25 years earlier, the aeronautical engineer had invented the jet engine and ushered in a new era of air travel. On May 15, 1941, an E-2839 experimental Gloucester, powered by Whittle's W1 power jet engine, took to the skies over Cranwell and flew for 17 minutes, reaching a top speed of 545 kilometers per hour. By the end of the war, the Gloucester Meteor had set a world speed record of 975.46 kilometers per hour. Thanks to the work of Whittle and German inventor Hans von Ohain, it didn't take many decades for jet aircraft to become the standard long-range transportation option. While the 1930s were a time of leisurely, luxurious travel, the 1950s was a decade of cheaper, faster flying, as more and more people experienced flight. Whittle's success put British aerospace at the forefront of the industry. American companies concentrated on piston-engined airliners, leaving the field free for the British to race ahead with jet technology.
Once again, the eyes of the world turned to Britain as aircraft manufacturers staged the greatest flying show on earth at Farnborough in Hampshire.
By 1952, national pride was at its height in Britain over the country's rapid development of jet technology. The best of the field were displayed at the Farnborough Air Show. Among them, the Supermarine Swift, the Gloucester Javelin, and the Handley Page Victor. There was also a glimpse of the airliners of tomorrow.
The Bristol Britannia, a turbojet capable of carrying 104 passengers, will soon be in regular service. Now the Victor, Britain's crescent wing bomber. Powered by 4 Sapphire jet engines, it's already in super priority production for the RAF. Few details have been released about the Victor, but there seems little doubt it's intended as Britain's #1 atom bomber. The huge Delta Wing Avro Vulcan. Britain pioneered and perfected the Delta Wing design. Now the Flying Darts, Avro 707s, the fighters from which the Vulcan was developed, form up in escort. Farnborough, our showplace of the air, proves once more that Britain is leading the world into this new jet age. As we looked at the latest aircraft that have swept Britain to the forefront of aviation.
But it wasn't all smooth flying for Britain's high-performance jets. Pilot John Derry was demonstrating the de Havilland 110 fighter at the air show. 4 years previously, he had become the first British pilot to break the sound barrier in a British aeroplane.
But those who watched during those 5 days could never know the feelings of the men whose job it was to take an aircraft through the sound barrier again and again. And perhaps as we thrilled to their daring, we almost forgot that on each and every flight, death flew with them. But those who were there on the 6th day will never forget. For it was on that day that a fault developed in Derry's black aircraft, and he and his observer flew in another. The aircraft broke through the sound barrier and then flew low over the airfield. Now the split-second disaster in slow motion.
As Derry pulled into a climb, the wings broke off the aircraft and the engines were torn from the frame, plummeting to the ground. One engine landed harmlessly, but the other crashed into a crowd of spectators, killing 29 people. Many more were injured. An investigation found that the de Havilland's D-nose leading-edge arrangement was unsuited to the stresses of supersonic flying in such heavy aircraft. The accident also led to a widespread reform of safety regulations at air shows.
The heavy death roll is mute testimony of the dreadful tragedy. Almost at once, Derry's friend Neville Duke flew a Hawker Hunter through the sound barrier again. Flying, like progress, must not stop. John Derry was an explorer in an unknown world, whose barriers can only be penetrated by such men as he. Their courage and skill have won us great victories in the skies, and they will go on.
Britain's aeronautical industry was buzzing in the years following World War II. The Vickers VC-1 Viking was an example of a new style of passenger aircraft. The twin piston-engine short-range airliner evolved from the Vickers Wellington bomber and went on to provide years of service for airlines all over the world. But importantly for jet development, it was a non-standard Viking fitted with Rolls-Royce Nene turbojets that became the first British pure jet transport aircraft in 1948. However, the first British passenger jets to come into service were powered by turboprop engines. With the Americans concentrating on piston-engined airliners, the field was left free for the British, who released the Vickers Viscount and the Bristol Britannia. Turboprop engines used the hot gas inside a jet engine to drive the propellers, providing greater power and speed than a piston engine and greater economy than a turbojet. New technology meant support jobs became more technical.
For example, to keep each airliner in the air today, over 100 workers are needed on the ground. But the safety of operations also depends upon the proper maintenance of planes. For this reason, many skilled mechanics must be employed. Their work is highly specialized, and those who direct or supervise such work must hold a federal government certificate and rating depending upon the type of work they do. For example, mechanics qualified to supervise work on general maintenance, including dismantling, welding, or fabricating, must hold what is called an A, or aircraft certificate. Others, who supervise and approve engine work only, are required by the Civil Aeronautics Authority to hold an E, or engine certificate. But no matter what their chosen field may be, regular apprenticeship courses or equivalent technical schooling is required.
Britain's flagship airline, BOAC, the British Overseas Airways Corporation, flew turboprops throughout the 1950s, taking advantage of the extra power and range to develop non-stop flights around the world.
Emerging from the war with tremendous military air strength, but little civilian, our airlines have since then been striving to make up for lost time. Informed observers of the British aviation scene believe that the United Kingdom has two trump cards to play in her bid for leadership in the sky. The bold, far-sighted policy of executives like Whitney Straight and her acknowledged genius in the design of new aircraft and engines. They point to Britain's intensive pioneering of gas turbines, prime movers which will outstrip by many hundreds of miles an hour the speeds accepted in present timetables.
There was plenty of competition in the aviation market, with France and India among the countries vying to provide the most glamorous travel experience.
For you, the new pleasure of travel in the latest luxury airliners, twice as fast, with personnel whose courteous attention is world famous.
I think we ought to have the lettering much bigger. Air India, the route of the magic carpet.
A diplomat, a movie siren, a world-renowned musician is usually aboard, and maybe sitting beside you. And remember, breakfast in bed.
Britain was determined to remain in the forefront of the aviation industry and flew the world's first turboprop aircraft in 1948. The Vickers Viscount was a medium-range airliner built at Vickers factory in Weybridge. Smoother and quieter than piston-engined airliners, the Viscount was capable of carrying around 50 passengers and went on to become one of the most popular airliners. 445 were built and sold to airlines all over the world. The Viscount was powered by 4 Rolls-Royce Dart Mark 525 turboprop engines and could fly to 25,000 feet. Later variants featured a new fuel system, 2-pilot cockpit, more powerful engines and increased weight. In 1949, the Bristol Brabazon took to the skies, a 100-seater airliner developed for the transatlantic market. However, the aeroplane never went into production and the prototype was broken up for scrap. The Bristol Type 175 Britannia turboprop was nicknamed the Whispering Giant for its quiet, smooth ride. It first flew in 1952. But when 2 prototypes were lost due to icing problems, its launch was delayed until 1957. Because of this, only 85 Britannias were made, but the aeroplane was still considered to be one of the greatest turboprop airliners ever built. BOAC bought 18 of the 312-type long-range airliners and flew them between London and New York, where they became the first airliners to enter non-stop transatlantic service in both directions. The RAF also operated several Bristol Britannias, flying them until 1975, when they were retired from military service and sold to African, Middle Eastern and European airlines, who used them until the 1980s. On the other side of the Iron Curtain, the Soviets were also moving ahead with jet airliner technology. When the Tupolev Tu-114 arrived at the Paris Air Show in 1959, Western observers were bowled over by its size and sophistication. The aeroplane featured swept-back wings at 35 degrees, Kuznetsov NK-12MV turboprops, the most powerful ever made, and landing gear that was exceptionally long because of the huge propeller.
The world's largest airliner with seats for up to 220 people, a range of 6,000 miles, so that it can fly easily from Moscow to New York non-stop. Well, the Russians have been photographing our planes in great detail while they've been here, so now no doubt they're going to allow us the privilege of taking a few pictures of theirs.
The Tu-114 flew international routes until it was superseded by the Ilyushin IL-62 and relegated to domestic routes. It was then pressed into military service and flew in the Soviet Army and Air Force until 1991. Although turboprops were proving to be efficient passenger airliners, Britain was still keen to introduce a turbojet into its passenger fleet. In 1952, BOAC took possession of the de Havilland Comet, the world's first jetliner and the jewel in Britain's aviation crown. American business magazine Fortune declared 1953 the year of the coronation and the Comet. Instead of the noisy whir of piston blades, the Comet's jet gave a high-pitched whine as it came into land. When it cruised at up to 40,000 feet, its passengers were settled in pressurized comfort.
Early in the year, a brilliant new all-British achievement made headline news throughout the world. The Comet made its debut on a journey from London Airport to Johannesburg. 4 de Havilland Ghost jet engines power this mighty passenger-carrying craft that the British Overseas Airways Corporation have adopted for their major air services. The Comet was soon airborne for its first historic flight, London to Johannesburg, a journey of more than 6,000 miles. Quickly and smoothly, the Comet climbed to 40,000 feet. At some 500 miles an hour, the Comet flashed over Europe. Always a new land, a new country to be seen, no time to be bored with the journey. Soon the Alps were below. Speed, reliability and comfort, these are among the Comet's greatest assets, backed by BOAC service second to none. Stewardess Audrey Cartmel looked after the passengers. High over Africa it flew, then below, white patches showing where gold had been wrested from the earth told the passengers that they'd reached their destination. This was Johannesburg. The Comet had made the 6,000-mile journey in 23 hours and 40 minutes, less than a day from London. The Comet's achievement thrilled the world and set higher than ever before the prestige of British aircraft and airways in this jet age.
Sadly, Britain's future in the air was not as assured as the nation had hoped. In its first year of service, one airliner was damaged and another was lost after failing to become airborne, later linked to a problem with the wing's leading edge. But there was worse to come. In May 1953, a Comet crashed during a tropical storm 6 minutes after taking off from Calcutta Airport in India. At the time, the accident was attributed to bad weather. However, in January 1954, a Comet exploded at 30,000 feet en route from Rome to London. There was no obvious explanation for the crash, which killed 35 people. Investigators ordered some modifications before allowing the airplane back into service, but they had no real idea what caused the accident. 3 months later, another Comet disintegrated over the Mediterranean. The entire fleet was immediately grounded indefinitely, while experts looked for the cause. Sir Arnold Hall headed the investigation, A brilliant aeronautical engineer, Hall had designed the compressor for Frank Whittle's first jet engine. The Ministry of Civil Aviation built a giant tank big enough for a Comet and flooded it with water to simulate the pressure of flying at 35,000 feet. Through extensive testing, Hall concluded that metal fatigue was to blame for the Comet disasters, caused by repeated pressurization and depressurization of the aircraft cabin. He found that the supports around the windows were punch-riveted rather than glued. As a result, the Comet underwent a major redesign, and the lessons learned were incorporated into other jets. In an intriguing footnote to the investigation, novelist and aeronautical engineer Neville Shute worked briefly for the de Havilland Aircraft Company in the early 1920s. In 1948, he published No Highway, a best-selling thriller about an aircraft engineer who becomes convinced that a new airliner type is fatally flawed due to metal fatigue. Shute called his fictional airliner the Reindeer, and people have since speculated that the novelist was broaching his suspicions about the Comet's design in a coded way, as Comet is one of Father Christmas's reindeer. In 1951, the book was made into a popular film, No Highway in the Sky, starring James Stewart and Marlene Dietrich. With the Comet out of action, the Soviet Tupolev Tu-104 was left as the only civilian turbojet flying passenger routes. Based on the Tu-16 Badger strategic bomber, the Tu-104 was tested in a water tank for its ability to withstand pressure before being introduced by Soviet National Airline Aeroflot in 1956. British company Avro eyed markets on the other side of the Atlantic. On the 1st of September 1950, it launched the Avro Ashton, an experimental jet airliner powered by 4 Rolls-Royce Nene 6 turbojets. Lessons learned from the Ashton were applied to the Avro C-102. Built in Canada, the aeroplane became the first civilian jet to fly into the United States.
In Toronto's Malton Airport, a Canadian Avro jetliner, a 4-jet, 60-passenger transport, takes off with a cargo of mail, climbs quickly to 20,000 feet, and heads for New York. "59 minutes later, she zooms over Idlewild Airport, cutting in half previous airline records for the 370-mile trip. The plane, called Canada's idea of a better mousetrap in the aviation field, is the first jetliner to carry international airmail in this hemisphere.
On Rome's Ciampino airfield...
But Britain was determined to assert its supremacy and get a redesigned Comet back into the skies. The government sang the praises of the new jetliner and put much effort into linking the successes of earlier airliners with the Comet's expected glory.
New records in recent days by British airliners highlight the great achievements of our aircraft industry in capturing world markets since the war. And outstanding among the market winners is the Vickers Viscount. Leading airlines in all 6 continents have bought the Viscount and come back for more. And it is widely acclaimed as the finest short and medium-haul airliner in service today. Over 1 million flying hours in all conditions have proved the Viscount a world beater. And once again in the news is the whispering giant, the Bristol Britannia, also a turboprop. In 1 year's service, it has set up 16 air records, the latest being the 13.5-hour Pacific crossing from Tokyo to Vancouver. This achievement was by a Canadian Pacific Airlines Britannia, and it cut by nearly a third the fastest scheduled time on the 4,700-mile trip. Britannias are taking over the Vancouver-Tokyo run as this reel goes to press, and the record is a fine start. In the de Havilland plant, production goes ahead on the Comet 4, latest and finest of our jet airliners. New York to Hertfordshire in 6 hours, 16 minutes. That's the Comet 4's newest record. The first of 19 Comet 4s is to be handed over to BOAC any day now, just in time to meet a powerful American challenge from this giant, the Boeing 707, which is going into Atlantic service with BOAC in the near future. The Boeing is a handsome and speedy job, but de Havilland engineers and test pilots believe the Comet 4 is capable of still greater achievements.
Mindful of the loss of public confidence from the early Comet disasters, De Havilland spent several years working on the new design. Despite pressure to change the name and create distance from the earlier model, de Havilland stood by the brand and by 1957 had produced Comet Mark IV. The new model was put through a rigorous inspection process, including pressure testing in a water tank, with additional stress applied by hydraulic rams on the wings. The Comet's setback had been a lucky break for the American aviation industry, which took the opportunity to catch up to the British with its revolutionary Boeing 707 jetliner. Based on the military KC-135 Stratotanker, the 707 had 70% more power than the Comet and could carry 179 passengers and twice as much fuel. Keen to get a jump on the lucrative transatlantic market, the Boeing 707 arrived in the United Kingdom to carry out tests in anticipation of launching flights between Britain and the United States.
The biggest, the heaviest and the fastest airliner flies into London Airport. It's the Boeing 707, America's rival to the Comet 4 in the race to provide the first jet airline service over the Atlantic. The Boeing, its 4 jet engines screened by huge silencers, is here to pass noise tests before it can use the airport. The massive interior will carry 165 economy class passengers, flying at heights that make individual oxygen supplies necessary for emergency use.
Spurred on by the American competition, de Havilland pushed ahead with the Comet. Despite its smaller range compared with the 707, BOAC placed an order for 20 aircraft as the Comet was capable of landing on existing runways and could fly to the many smaller airports along BOAC's air routes. It was the beginning of the end for BOAC's piston engine fleet. According to pilot John Cunningham, despite its advanced technology, the new aeroplane was easier to fly than the earlier Comets.
How does she compare with the earlier Comets?
Well, it's very much more lively, having more than twice the power of the earlier Comets. Its flying qualities are much improved over the earlier Comets, partly as a result of the last 8 years' flying experience on Comets. And generally, I think it's an easier aeroplane to fly than the earlier Comets.
Are you absolutely confident that you've straightened out the problems which caused the earlier Comet disasters?
Yes, absolutely. We've learnt an enormous amount, of course, in the last 8 years, and particularly in the last 4 years, as a result of the Comet inquiries. A lot of research and development work has been made on structures, and we have today in the Mark IV an aeroplane that embodies really all the best experience that any manufacturers had.
The Comet featured simplified controls to assist flight crew with the increased landing and takeoff speeds. Its first big test was the race to cross the Atlantic. Pan Am was confident its 707 would be the first, but BOAC had a surprise in store.
It was a great race and Britain won it. Comet 4 Delta Charlie flies into New York, the first jet to carry fare-paying passengers across the Atlantic. And Comet 4 Delta Bravo clinched the victory with a record non-stop west-east flight in 6 hours, 7 minutes on the same day. The first commercial jet service across the Atlantic is established, and BOAC are flying it. For the 28 passengers, it was a great occasion. But for the team who flew her and the men who built her, Delta Bravo's capture of the blue ribbon of the Atlantic Airways was final triumph. Such men as her captain, Tom Story, and the man whose genius created her, designer Tim Wilkins.
Mr. Wilkins, you've designed a wonderful aeroplane. Have you had much in the way of trouble on the way?
Well, we had, of course, our full measure of troubles with the Comet 1, which was designed some time ago, and was, of course, a very big step forward in the aviation airline business. Anyway, after the troubles, we did decide to carry on with the Comet and retain the name and bring it back.
Comet's story stretches back into the war, when Britain's all-out effort to produce fighting aircraft gave her no chance to develop civil types. But Sir Frank Whittle's first jet engine gave the opportunity to forge ahead again. For 13 years, development of the Comet went ahead at de Havilland's. First, Comet 1 and failure. Then, the bigger, faster, safer and better Comet 4. But America's research was bounding forward, and after the setback to Comet 1, it looked as though the Boeing 707 would be first across the Atlantic. Everyone believed the race had gone to the United States, and Pan American spent an estimated £500,000 advertising the first transatlantic jet service. Everyone believed it except de Havilland's and BOAC, and they'd a surprise up their sleeves. Early delivery of not one, but 3 Comets. And that did it. More than a month ahead of their own schedule, and 3 weeks in front of the Boeing's expected entry into service, BOAC sent off the first regular jet service across the Atlantic. Yes, Comet 4's in business. Britain's aircraft industry can chalk up its greatest post-war triumph.
As well as the Comet 4, Britain was counting on another jetliner to keep it in the forefront of the jet race.
So, George, what can the VC-10 do?
Well, the passenger accommodation varies between 108 and 150 people according to the class of layout. Cruising speeds in the 600-mile-an-hour class. Cruising height between 40 and 50,000 feet according to the length of the trip. The range, London, New York, non-stop.
Why are the engines on the fuselage and not on the wings?
Because the aeroplane has to be better than the American jets, which will be in service some years before it. And the biggest problem in these big jets is aerodrome performance. If you keep the engines away from the wing so that you've got them pulled back with a clean wing, you can develop a takeoff performance of the aeroplane much superior to the one which you have with the engines on the wing. You have a completely clean, unbroken leading and trailing edge flaps, and you get out of difficult aerodromes at greater weights.
What about for the passengers? Is there any improvement for them?
Yes, so there's going to be a big advantage in passenger comfort because the noise and vibration, whatever there is behind them, and forward of that line, say, the interior is going to be pretty quiet.
The VC-10 and the giant Vickers Vanguard turboprop were trumpeted as the way of the future.
The wooden mock-up of the Vickers-Armstrong VC-10 indicates the shape of things to come in British airliners. The cost of the mock-up is £500,000, showing that building large airliners is a big money business. The VC-10 will carry a maximum of 150 passengers at about 600 miles an hour, the power being provided by 4 Rolls-Royce Conway engines. It will be in the air by 1961. The engineers concerned believe that engines mounted in the rear are best. But the VC-10 isn't the only aircraft built at Weybridge. There's the Vanguard too. Turboprop, twice as big as the famous Viscount, it will fly on BEA routes next summer. The VC-10 could reduce tourist fares by 50%. Roll on the day when it's in the air.
The Vickers VC-10 was to be the first big jet airliner with 4 rear-mounted engines. Manufactured at the Weybridge factory of the British Aircraft Corporation, the 150-passenger aeroplane was intended to be the world's most powerful airliner. By mounting its 4 Rolls-Royce Conway 301 turbofan engines at the rear, cabin noise was significantly reduced. The aircraft also featured a strengthened airframe, with more than half manufactured from solid steel and alloys, and fully duplicated systems to enhance safety and reliability. Despite heavy promotion of the capabilities of the VC-10, especially in the face of growing American competition, the Vickers company was on a knife edge, as there appeared to be little demand for the jetliner. The British government intervened to pressure BOAC into ordering extra aeroplanes to allow Vickers to break even on the deal, if not make a profit. BOAC was concerned that the VC-10 was not fuel efficient enough to be profitable. Its secret calculations that the Boeing 707 would cost only £4.10 per passenger mile, compared with the VC-10 cost of £4.24 per passenger mile, ended up in the papers and lost customers for Vickers. Eventually, BOAC ordered 12 standard VC-10s and 35 super VC-10s, although it cut its standard order to 7 in 1964 as airline growth had stalled. The British government bought the excess VC-10s and used them as military transports for many years. The super VC-10 incorporated an extra fuel tank in the fin and a change to the engine position, resolving a problem with tailplane buffeting and fatigue issues associated with the thrust reverser operation. Despite the political machinations that underlay its development, the VC-10 quickly became one of BOAC's most popular aircraft, with both passengers and crew enjoying the reduction in noise and the enhanced interior comfort. The Vickers Vanguard was a further development of the Vickers Viscount. The redesigned fuselage featured a double bubble cross-section, providing more internal space and increased cargo capacity. New Rolls-Royce Tyne engines powered the Vanguard, enabling the aeroplane to cruise at 30,000 feet and become one of the fastest turboprops ever built. The four engines were exceptionally reliable and economical, and the Vanguard could cover a range of almost 3,000 kilometers. Unlike earlier craft, the Vanguard's wings contained integrally machined skins of light alloy to provide span-wise stiffening at low cost, and 3 shear webs rather than the single spar in the Viscount wing. The aeroplane required a lot of physical strength to fly, as all of the flying controls were manually operated with no power assistance. There was also a massive yaw induced every time the thrust was altered, as the 4 huge props all turned the same way. Unfortunately, by the time Vanguards were delivered to the market, turbojets were in the ascendancy, and there were very few orders for the giant turboprop. TransCanada Airlines and BEA were the only customers, thus only 43 Vanguards were ever produced. The BEA Vanguard serviced the busy European and UK trunk routes. With a configuration of 139 passenger seats, the Vanguard turned out to be very profitable. And on shorter distances, the aeroplane could even match the traveling times of jets flying the same routes. More passenger seats brought down the price of tickets, and for the first time, people considered flying medium to long distances rather than driving. Airline travel started to become accepted as a fact of everyday life. In spite of the various setbacks in the British aviation industry, the government was happy to take the King of Nepal on a well-publicised tour of the Vickers Armstrong factory when His Majesty visited England in 1960. The King was greeted by Brigadier General Sir Charles Dunphy and Sir George Edwards, then taken to the Vanguard erecting shop and shown completed aircraft on the tarmac. While the King was mostly photographed with the civilian airliners, the purpose of the visit was to show the monarch the Vickers Armstrong range of military hardware, one of Britain's most important export industries. The second short-haul jetliner to enter service was the British Aircraft Corporation 111, which underwent tests in the early 1960s. The prototype crashed on the 22nd of October 1963, killing all on board. An investigation uncovered the phenomenon of deep stall caused by reduced airflow to the tailplane because of the blanking effect of the aft-mounted engine nacelles at high angles of attack, preventing recovery of normal flight. Stick shakers and stick pushers were added to the control system, and the wing's leading edge was redesigned to smooth airflow into the engines and over the tailplane. Another test version made a heavy landing at the Wisley Test Centre, crushing its landing gear and slicing off the undercarriage. But the airliner went into production and became a successful airline transport for many years. The first jet airliner to go into production in continental Europe was France's Sud Aviation Caravelle. The elegant twin-engine turbojet made its first flight in 1955 and came into service 4 years later on the Paris-Rome-Istanbul route. The aeroplane could seat up to 128 single-class passengers and carried a flight crew of 2 pilots and 1 engineer. Although the Americans had been initially left behind in jet airliner development, Lockheed's propeller-driven airliner, the Constellation, became one of the most popular post-war passenger aircraft.
Now watch this. Feather 1.
Feather 1.
Feather 2.
Feather 2.
Look at that, on 2 engines. Purring along just like a kitten. You haven't seen anything yet. Feather 3.
Feather 3.
Boy, oh boy, look at that. On 1 engine. Going along just as steady as you like. Only a Constellation can do this. Why do we have all that tremendous reserve of power? Because, my friends, power means safety. That's why this Super Constellation is the most dependable airliner in the world today. Okay, Hugh, bring in 1.
Unfeathering 1.
The Connie was the first pressurized airliner in wide use and was flown by airlines all over the world.
Gear down.
Gears coming down.
Eastern 601, clear to land. The captain will reverse the pitch of the propellers and push the air forward and just stop the plane. There. You see, that acts as a powerful brake. So next time when you're riding in an airliner and you hear the engines roar soon after you're on the ground, remember that's what he's doing, reversing the props to stop the airplane.
Constellations held their own throughout the 1940s and 50s until the advent of jet transport finally brought on their retirement. Jets made mass transportation a reality. America envisaged a golden future for its new Boeing 707 airliner.
Flight 1000's destination, London. Luggage was prepared for loading, and all other routine pre-flight activities were taking place. 1000 seemed to be just another flight to London, in all respects except that its passenger list was twice as large as on ordinary trips. Flight 1000 was airborne, but no plane was used. This was the first of so-called airline paper flights, a complete simulation of an actual flight that's been repeated more than 2,000 times since. The reason? To prepare for the revolution in transportation that is now here, the advent of commercial flying by jet clipper. In those early days, weather information for Flight 1000 and all the other paper jet flights was gathered as carefully as if real jets were to cross the Atlantic, gaining invaluable advance information about jet travel. For example, it is now known that at the altitudes at which jets cruise, generally 30 to 40,000 feet, flying will be above the weather. After years of paper flights like number 1000 and many hundreds of real flights with prototypes, the jet age is now here. The jet age begins before takeoff at the airline's new terminal, now under construction at Idlewild Airport, New York. Jets are parked around it, as in this model. Passengers will board by walking along a covered ramp directly to the cabin level. Ground transportation delivers travelers directly to check-in counters. The circular design of the terminal, along with its unique cantilever roof, will assure speed of service and convenience for passengers. This is it, the first American commercial jet capable of economical transatlantic service, the Boeing 707 Jet Clipper. First to go aboard cargo and mail. Cargo shipments will be able to reach Europe in just 6.5 hours. A letter posted in London or Paris after the close of business may arrive in New York the same night and be waiting for the addressee at his breakfast table or office the next morning. Speed is a byword for every part of jet operations, since with some arrangements of seats, more than 150 passengers can be accommodated. There is an entrance at the back and the front, while plane servicing facilities are on the far side. One indication of the staggering impact of jet travel, every one of the airline's dozens of jet planes can carry as many people in a year's time as the biggest ocean liner.
The 707 featured 35-degree swept-back wings and 4 Pratt & Whitney JT3C turbojets. It was the height of aviation technology. But before the 707 could go into service, there were still some hurdles to be overcome.
More jet news from Seattle, USA, where the new Boeing jet airliner, America's challenge to the Comet, is all set for her first taxiing tests. All seems well with the 95-ton giant, then a sudden collapse as the port landing gear buckles. Fire trucks race to the scene as the pilot and crew scramble out of the damaged aircraft. The jetliner cost nearly £6 million to build. Experts fear that its first test flight will be delayed many weeks.
As the design was refined, anticipation built.
Takeoff, without any need for engine warm-up, with outside noise now reduced to no more than that of propeller-driven planes, capable of traveling at 575 miles per hour or more, much higher and faster than you've ever flown before. The first passenger jet clipper to fly the Atlantic. Because of its greater size and speed, it will do the job of several of the biggest propeller-driven planes. Welcome aboard. Welcome aboard the spacious cabin, attractively decorated, air-conditioned but draft-free. Newly designed individual overhead light units are an innovation. Roominess extends even to the powder rooms, which look like those in a private home. And a new sensation, complete absence of vibration. Near sonic speed, but inside one of the most stunning discoveries. There is no feeling of movement at all, no vibration, hardly any sound. A new concept in air transportation. The travail has been taken out of travel.
Ladies and gentlemen, this is your captain speaking. We're now at cruising altitude, 35,000 feet. Our flying speed is 575 miles per hour. In addition, we're benefiting from a substantial tailwind by courtesy of the jet stream. Hence, our ground speed is now approximately 658 miles per hour. Indications are that our arrival at London Airport may be ahead of schedule. I'll be speaking with you again from time to time. Thank you.
In spite of being pipped at the post by the Comet 4's unexpected transatlantic crossing, when it went into service 22 days later on the 26th of October 1958, the Boeing 707-120 was an impressive sight. It flew from New York to Paris with a fuel stop in Newfoundland. The 707 soon outstripped the British jetliners in popularity, but some unfortunate incidents shook the public's faith in the airliner less than a year later. The jet was plagued by a series of mishaps, many of which were emergency landings caused by failures in the plane's hydraulic system. One crippled jet was filmed coming in to land at Idlewild Airport, trailing a spectacular train of flames as it screamed to a halt. Although emergency slides were deployed as a precaution, most passengers disembarked down the stairs. The day before, a Qantas 707 had suffered an engine failure 150 miles out to sea. Fortunately, the aircraft, with 82 people on board, was able to make it safely to land on the other 3 engines. The first critical accident occurred on the 17th of August 1959, when a Boeing 707 crashed shortly after takeoff at Long Island, New York, while on a test flight, killing its crew of 5. Rescue crews salvaged as much of the airplane as possible to help with the investigation, which was carried out by the U.S. Civil Aeronautics Board. Investigators found that the pilots were simulating engine failure of 2 engines on one side when they crashed. After the accident, the Federal Aviation Authority introduced a requirement that 2-engine-out flying could not be carried out under 5,000 feet. Concerned that their flagship airliner could suffer the same fate as the first Comet, some politicians called for the 707 to be grounded. However, Boeing defended its jetliner.
Saturday's Long Island crash, when the crew of 5 were killed, followed more than a dozen incidents ranging from minor electrical faults to landing gear trouble and wheels dropping off. These facts will put power reporter Douglas Brown to a Boeing Airplane Company executive, Mr. Bromwich.
Well, it is true that we've had a certain number of difficulties with the 707, but these troubles have not fallen into any pattern. That is, there haven't been any consistent troubles with the 707. We have had some hydraulic system troubles, but as far as the major incidents are concerned, they've all been a little bit different one from the other. So we can't say that we have a family of troubles here that we can really work on.
Awful lot of them, though, isn't there?
Well, I suppose so, but every airplane that's introduced into service has difficulties at first. We probably have had a little bit more publicity than the other people have had because, after all, it's a new device, and people are interested in what happens to transportation devices. Witness the headlines that occurred when the Queen Mary ran into, or was it a freighter ran into the Queen Mary?
Influential people in the United States themselves have called for the aircraft to be grounded.
Well, of course, we had a member of the House of Representatives call for it to be grounded, but there are 486 members of the House of Representatives, and I'm sure that out of these 486 people, you could find at least one who likes to get his name in the paper.
Is there anything in the criticism that the 707s should have been tested more on the ground before they were allowed into the air?
Well, from the Boeing airplane point of view, I don't know what we could have done. We've spent an awful lot of money on the airplane. We've actually started designing the airplane in 1952 and first flew the airplane in 1954. We have spent a great deal of money on it, and as we look back on the thing, I don't know that anybody in the company could say that there are things that we shouldn't have done in the way of testing.
Regardless of its problems, Boeing still had a commanding lead in the aviation industry. But coming up behind was Douglas Aircraft with the DC-8, another 4-engined jetliner. When Boeing commenced delivery to Pan American Airways in October 1958, Douglas pushed forward its testing schedule, sending 10 aircraft to be certified by the Federal Aviation Administration by August 1959. A number of remedial works were carried out, including replacing air brakes with engine thrust reversers and adding leading-edge slots to improve low-speed lift. In September 1959, the first DC-8 entered service with Delta Airlines and United. 2 years later, a DC-8 became the first civilian jet to make a supersonic flight. Although the 707 was regarded as the superior aeroplane, the DC-8 proved to have greater staying power. In 2002, of the 1,032 707s manufactured for non-military use, just 80 remained in the air. Of the 556 DC-8s that were built, around 200 were still in commercial service. Some are still in use as cargo planes. But ultimately, the jet age belonged to Boeing, and the 1960s saw the aviation company take a firm hold on the American market, as well as spreading its tentacles out to the rest of the world.
After 84 minutes, the first flight ends, and congratulations go to the pilot for blazing a new trail in the sky.